Okay. Now don't confuse while solving the problems in the block diagram. Just use a few steps. Steps to simplify. Steps to simplify block diagram. Steps to simplify the block diagram. Step 1. First, series or parallel or any loops are available in your block diagram. You first identify, is there any series combination, cascading or parallel combination or loops. First you simplify those things. First priority is this. Second priority is interchange takeoff point or branch point. Takeoff point, or we call it as a branch point. Okay. First do maximum concentrate on series and parallel combination. Third one is interchange of summing point. Interchanging of summing point is the last priority. Is the giving the last priority to interchange the summing point. Okay. So interchange the summing point is the last priority while simplifying the block diagrams. Okay. You follow these rules first. First is series, any series combination or parallel combination or loop combinations, you first finish that, or interchange the takeoff point or a branch point first. Okay. And the last priority is interchanging the summing point. Okay. While you are doing the problems, while you are solving the block diagrams, remember these 3 steps in your mind, such that you have a correct direction and a correct way to solve the problem. Okay. Note down. Now see this one. Now this is one block diagram here. Okay, I just identify here. This is one branch point. This is another branch point. Okay. So now this is the input R of S. This is the output. When the input is same, yes, input is same. So the gain at takeoff point 1 is here how much? G into something. Let us assume x into G. Now what is the gain at takeoff point 2? Let us assume here y into G, which means that now gain at takeoff point 1, which is equal to gain at takeoff point 2. If these two gains are same at 2 different takeoff points, we can interchange those takeoff points with a condition of gain at takeoff point 1, which is equal to gain at takeoff point 2. If these two gains are same at 2 different takeoff points, you can interchange those 2 takeoff points. Means now you can draw the circuit like this. You can interchange those summing points, takeoff points So I just take this summing point here and this summing point to there. So you can interchange those takeoff points, branch points. Now a bottom branch point is shifted to top side. And now this branch point is shifted to downside. Okay, so you can interchange those summing points. Now see here. Now these branch points are interchanged. Now this 2 and this one is 1. Not, you can interchange. This 1, 2 becomes interchange. Okay, so now this is very easy. Now this is forward path gain and a feedback path gain, and this is a positive feedback. So you can remove this, and this is G by 1 minus GH because positive feedback. Now this is also forward path, negative feedback path, but this is also the positive feedback. So this is a positive feedback, which is G by 1 minus GH. Now this is the forward path and this is the forward path, G by 1 minus GH, G by 1 minus GH. Now both are in a forward direction, and this is, both are which operation? Parallel operation, right? Now these two are the parallel operation, such that then what is the transfer function now? See here. Now this is the transfer function. Now both are connected in parallel. Therefore, now the parallel combination is nothing but G by 1 minus GH, G by 1 minus GH. Therefore, now the transfer function C of S by R of S, which is equal to G by 1 minus GH plus G by 1 minus GH. The overall operation is 2G by 1 minus GH. This is the transfer function. Okay. Note on this. Now in this problem, he is giving some linear equations. Okay, he is giving some linear equations. What is given is y2, which is equal to y1 plus 2y3, y3 which is equal to 3y2 plus 4y3, and y4 which is equal to 5y3 plus 6y4 plus 7y5, and y5 which is equal to 8y4 plus 9y2 plus 9y2. Okay, so these are the some algebraic equations which is given, and he is asking to find draw signal flow graph, loops, non-touching loops, identify. Okay, draw the signal flow graph, identify loops, non-touching loops, and okay, that's it. Okay, now see here, slowly we can construct. So let us assume this is one node y1, this is another node y2. Each variable has one node y1, y2. What he is asking, y2 equal to y1, okay, right, and y2 equal to 2y3, okay, y2, and this is y3. So from y3 to you want a y2. So with a gain of, this is a feedback, with a gain of 2. So y2 equal to y1 plus 2 y3 is clear. Next y3, what is y3? y3 equal to 3y2, y3 equal to 3y2 plus 4, sorry, this is 4y4. So y3 equal to 4y4 means this is y4, okay, matching, and this is y4, and he is also asking y3 equal to 3y2 plus 4y4, right? Now y4 equal to 5y3, enough, plus 6y4, here is 6y4, this is 6y4 itself. y4 equal to 6y4, now plus 7y3, 7y4, this is y4 node. Now y4, this is y5, so 7y5, clear or not? Next y5 which is equal to 8y4, y5 which is equal to 8y4 plus 9y2, plus 9y2, where is y2? y2 here, so this is y2 9. y5 equal to 9, right? Now this is a signal flow graph. Now this is the signal flow graph. First question is completed, signal flow graph. Second question is loops. Identify the loops. Loops identifications. Now what is the loops identification? Now see here, this is one loop L1, this is another loop L2, this is one loop L3, this is another loop L4, and okay, that's it. No, there is no loop, right? Now this is 4 loops. Total loops are, identification loops are L1, L2, L3, L4. Next, non-touching loops. Non-touching loops are, a combination is L1, L2, L1, L3, L1, L4. Next, L2, L1, L2, L3, L2, L4. Next, L3, L1, L3, L2, L3, 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 L4, L4, L1, L4, L2, L4, L3, L4, right? Now, what are the combinations? Which combinations are existing? L1, L2, L1, L2, common node, no, touching loops. L1, L3, yes, L1, L3, yes, common, there is no common node. L1, L3, yes, common node is no. Okay, this is correct. Next, L1, L4. L1 and L4 are also non-touching loops. Okay, correct. Next, L2, L1, no, wrong. L2, L3, wrong. L2, L4, wrong. L3, L1, both are same. Okay, L3, L1 are same. This is already covered. L3, L2, wrong. L3, L4, wrong. Next, L4, L1, that is also over, is already over. L4, L1, this is over. Now, L4, L2, wrong. L4, L3, wrong. Okay. Now, these are the non-touching loops, all are same. So, these are the two non-touching loops. Is it right or not? Okay, no doubt. This is also very important. Now, he is giving the equations like this and he is asking to find, draw the signal flow graph and identify the loops, identify non-touching loops, identify forward paths, how many number of forward paths are in the previous questions are like this. Somewhere he is writing some A or B, at B, A to B, how many forward paths, B to C, how many loops, C to D, total number of individual non-touching loops, like that the questions are asking. Okay, hold on.